4.7, okay? We talked about it yesterday, but everything that we've been doing up to this point has been when we are giving that angle measure. Let's say it's sine, and we know that the sine of theta is going to equal to that y value. So what's been given to you up to this point is like 120 degrees, or pi over 4, and then we were always searching for that y. Well, what we're going to do today now is, instead of searching for the y, we're going to work backwards and solve for that independent variable theta. And maybe we're given that y. So it's just working with our trig functions in the reverse fashion. And I can't state this enough. Theta is always going to represent a what again? Theta is the angle, okay? It's going to be an angle measure. So that's what we're looking for today, is we're given the ordered pairs around the unit circle, and we're going back and saying, oh, that was 120 degrees, or 5 pi over 2, whatever. So we are going, still the trig functions, it's still the unit circle that we know of, it's just going in the reverse fashion. So if we're going to solve backwards for that independent variable, we need what we call this inverse trig function. And that's what the -1 represents. And I really don't care for the way the book defines it with x and y. Again, typically we'd like to say the sine of theta. Sine of theta is equal to y, but they're just, I maybe should have used a and b in replace of it. But long story short, if we start over here on the right, sine of y is equal to x. If we want to solve for y, that means we need to take the inverse sine of what our equal to was before, which was our x. So basically the x and the y is flipped places, and now it's the inverse. Because again, the inverse of addition is subtraction, the inverse of multiplication is division. Well, what's the inverse of a trig function? It's the inverse trig function, and that's why they named it as so. They're also going to use this term arc sine, or arc cosine, arc tangent, arc whatever trig function you're working with. The arc is just another way of saying inverse. Okay, so they're two of the same. This was, in my opinion, this was kind of the old school terminology for it. And then somewhere along the line they said, let's not use arc anymore. That's 3 letters. Let's just go down to a -1 sign. But again, it means the exact same. So arc sine, inverse sine, all good. And so I'm going to use this definition that they have in the book, but probably what, again, I prefer is if we had the sine of theta was equal to y, right? So if we wanted to solve for theta, now it'd be the inverse sine of that y will get us theta. And we could use the same reasoning for cosine. Cosine of theta is equal to x. So if we wanted to solve for theta, inverse cosine of x is equal to theta. We can do the same thing for tangent. Tangent would be y over x. So unit circles, if you don't have them out, go ahead and let's take a look at those. It does say to find the exact values, or state if it's undefined. So exact values means unit circle. We got the inverse sine of square root of 2 over 2. Where is our y value? Square root of 2 over 2. Anybody find it? Kind of just turns into a XY search is what it does. Anybody find a degree measure yet?
It's 45 inches.
exactly. I'm going to go ahead and write this out. It's probably a lot more writing out than what we need. 45 and 135. If we were to write the radian measures for that, it would be pi over 4 and 3 pi over 4. And actually our correct answer, if we had to choose one, it's going to be pi over 4. Just hang on to that thought. We're going to talk about that here in a minute, why it's the pi over 4 and not the 3 pi over 4. But yes, this is a really good example of illustrating that when you do this, more than likely there's going to be two angle measures that can get you that exact amount. Okay, let's go ahead and move on. Arc sine of -1. Arc sine of theta is equal to y. Arc sine again means inverse. Our y value here is that. So theta is equal to the arc sine of -1. Y value. Where's our y value, -1? Think about -1 being the y value below the x-axis down there at 270 degrees. That would be at 3 pi over 2, which is also negative pi over 2. And we'll talk about why we say negative pi over 2 here in a minute. Lastly, inverse sine of -3. Will we ever get a y value of -3 on the unit circle? No, it's not possible, right? Why is it not possible? Well, because we know we have a radius of 1. The biggest y value we could have would be like 1 or -1. So this is not possible, therefore undefined. So there's kind of the idea behind all of it. And now here's the reasoning why. Inverse trig functions, looking at the restricted values. Example number 1 was a really good example of two answers there, pi over 4 and 3 pi over 4. And why did they choose pi over 4? Well, because when it comes to sine, we are going to take, if we can only choose one answer, we're going to take that one answer that occurs on the right side of the unit circle, which goes from the range, you may not like this at first, but negative pi over 2 to pi over 2. We would like to say 3 pi over 2 to pi over 2, but that is actually opposite. That would be over here, if that makes sense. So that's why they go negative pi over 2 to pi over 2. So if you need to write that, negative pi over 2 to pi over 2. How do we remember it's right side? You ever notice when you're driving where are all of your signs at? Left or right side of the road? Right side, right? So sine is the right side of the unit circle. Cosine. Cosine is now the top side, top half of the unit circle. That range is from 0 to pi. Don't really have a reason for that one. I just know that sine and cosine are not the same, so sine's on the right and cosine's on the top. If you come up with one, let me know. And tangent, that's actually the same thing as sine. It's going to be on the right side there. So again, negative pi over 2 to pi over 2. Now we're getting really tedious here. Notice the sine it could be equal to pi over 2. This should have been a dashed line here. I messed up, but notice it's not equal to, and I can't remember if we get into an example here of that or not. But to show why it can't be negative pi over 2 or pi over 2. Let's go ahead and finish with example number 2. Find the exact value. Cosine x or y x. Where's your x value? -1. Yeah. Hopefully you're starting to just kind of visually think of it. We're in a plane, x value -1. It's over there on the left, and we know it's pi over there. So it's like you almost got a mental photograph of that in your head already. You're going to get to the point with these 90s, you'll just kind of know it. And now we get into tangent. All right. So unfortunately, this one's not as easy as just looking for the x or the y. We are actually looking at the ratio of y over x. Okay. So what we're going to do now, and I'm going to do it on a separate sheet of paper. If you need to do it on the side or somewhere, that's fine. But let's go ahead and look at like 300, 315, and 330. We're going to take some time and we are going to identify these ratios for ourselves. And then these ratios will be kind of used for all of these when it comes to tangent or cotangent. We can start with the easy one. Let's go with 315 degrees right here in the middle. If you go to your unit circle, that was square root of 2 over 2, comma negative square root of 2 over 2. If I take the y value over the x, y over x, negative square root of 2 over 2 over square root of 2 over 2, what does that reduce down to? -1, right? So at the 45 multiples, again, this would have been the same up here at 45 degrees. Your tangent is -1. Okay? And it's the reason because tangent is y over x, and they happen to be the same. So if you see tangent of -1 from now on, you know you're going to look at your 45 multiples. Let's go to the other ones that are not as nice. If we look at the 300 degrees, that ordered pair is 1/2 negative square root of 3 over 2. Once again, here, y over x, negative square root of 3 over 2 divided by 1/2. Negative square root of 3 over 2 times the reciprocal. So at this location, 300 degrees, it's negative square root of 3. And then lastly, if we look at 330 degrees, that is the square root of 3 over 2, comma, -1/2. One more time, y over x. Twos cancel. I'm going to save us a step and say that's square root of 3 over 3. So basically what we did here is we just solved 3 different problems. We did 300, 315, and 330. But now, as you go to do this in the future, you have these values. So I would keep these somewhere in your notes. It's going to save you a lot of time. It's going to save you some frustration too. I said 15 minutes, didn't I? We are just about there. If we go back to this one now that we've done all the legwork, we got negative square root of 3 over 3. Which one of those 3 measures was square root of 3 over 3? Yep. Or 11 pi over 6. Typically they want the radian measure, if you haven't caught on to that. You know, if they specify the degree measure, then you can give 330. All right. Lastly, arctan of 0. Okay. Where is 0? Well, again, it's got to be y over x. The only way to get 0 is if that numerator is 0. Therefore, our denominator would have to be 1. So where the y value is 0 and our denominator is 1 or -1. If y is 0, that means it has to be on the x-axis. So it's over there on the right at 0 degrees. or 0 radians.